So this is just an example now of the force needed to climb over the Nazca plate is calculatable. This tube in our club, she broke the programs up for me. There she's put the subduction, creation, and the breaking of the continent apart and seafloor stretching. And here she's got the 4 stages of subduction, which is all to do with the momentum of the moving continental plate. The same forces are applicable to metamorphism, rotation of all your sedimentary beds, your folding of them, your uplifting to the top of the Andes. You can now, if this take a cut through the earth, we should be able to see the distance traveled downwards for the pressure and the heat, and determine whether the metamorphic reactions to determine the forces on them. The same man that's pushing this and the earth crust is pushing this together to give you your metamorphic and give you your earth topography. And this is now in contradiction to the Wilson cycle, where you have you have the continents all together, you have divergent convections coming up, splitting them apart. Later on, they converge and and then they pull one of them down. This goes from anti-clockwise to clockwise. Now it's gone anti-clockwise. Now the whole lot get together again. It's got no logic to it. It's just a sequence of events with the unnamed forces. Mr. Wilson, I'm challenging you. I'm challenging you. There's the Maurer cycle. There's our Earth being rotated by the sun. There's the equation which tells us how it's breaking up on the surface. There's seafloor stretching. We've got metamorphism, erosion, and redistribution. So over a period of 250 million years, we've gone from that shape of the crust to that shape. And small changes, even as agreed by Caltech and the Earthwide Project, will change a small change in the position of the center of mass, and the whole thing starts all again. So my cycle is completely continuous. There is no sudden turning around of forces. It's a continuous, unrelenting regeneration of our planet. We know about it. That happens because in the Andes, they're coming up oceanic lithosphere, which is subducted or forced under, plus what's on the surface, and which gives us the mineral andesite. So we know that actually happens. It's the recycling of our lithosphere, and that is, if you go to Scott Ceesay with his lovely animations, this happens every 500 million years. So at this stage, we now leave it all together. We're running out of time. We go on to Professor Shiga sent me this. The movement, the arrows are showing that the Philippine and the Japanese are moving into the Pacific Basin, not as distinct from the Pacific Basin, subducting under it. Again, he has found a practical example where the explanation is much easier to consider. If you look at the Philippines and the Japanese arcs, they're moving forward onto the oceanic crust, not being pulled up from underneath. And for that, he produced this diagram he's allowed me to reproduce this for this talk. And there is his faulting, and the continental crust rides over the oceanic crust. This is an observation, a case point. And there he's got this information too from the National Oceanic Organization, which and together it looks very much like the explanation of the crust being pushed rather than the oceanic crust being pulled. Can give you a much better explanation of the movement of these two peninsulas, which were broken away from the main Eurasian plate when India smacked into it. And this he also sent me. This is difficult to show, but this is Japan. Comprises 4 islands, and this is if I can get it working, it will be the video showing what happened at the earthquake 11 years ago. So we'll try and switch this earthquake on now. and see if I can get it to start. Okay, can you see this on the screen? The Hokkaido, the island, this is turning anti-clockwise. The bottom Shikusa, how you pronounce it, is turning clockwise. All the stress lines are now coming onto the middle. Look, it's years at a time going over a period of years. As all this is turning anti-clockwise. Look at that. The stress lines are now looking different. As we're coming up to 11th of March, it's unbelievable. You can see all the forces, slam, bang, wallop. There's your earthquake. It's unbelievable. It's all been plotted. Look at your stress lines. You've actually twisted this anti-clockwise. That's gone anti-clockwise. There you can see the arrows. Then you've got your 4 islands, Kyushu, Shikoku, Honshu, and Hokkaido. And you've got a fault line of the Eurasian Amber Plate, and it's on that fault line. You cannot explain this by subduction. You can only explain this as by the circumferential forces moving this out. So if we go on to this again, it's no different to if you smack a piece of metal into a shape, this side would come up and that side would come up. It's exactly what happened with those islands. This is the downward force, a circumferential force is pushing this forward. And this makes a more logical argument. They're starting again. You may be able to see this fantastic video. Bang, coming, there it goes. There she blows. It's fantastic. Professor van Hinsbergen, I've been invited tonight, and he helped me. So allowed me to use his papers. There's been 3,400 papers written on the movement of India to Asia. But you can see this is Greater India. It's accumulated of scrapings off the bottom, a melange, you might call it. We call it the accretion re-wedge. And now it's starting at the part at the Morondova plate where liquid province, where the magma's coming in. This is starting to twist. Look, it's changing attitude. And then by the time it hits the place where the Deccan Flats come through, this is now rotating quite significantly. And finally, it's smacked to India where all this is crumpled. I modeled this not on I used his, with permission, his graphs, but I've used a separate method of interpreting it. I see it as a car skidding with the magma coming through. It's lost friction. It's a momentum-driven job, not a subduction job. And zoof, it's gone off course and it's veered. There's no other rational way that you could have subduction currents going that way and on Australia going that way on the same hemisphere. It just wouldn't work. And what is more, that if this is the case and I'm right, then we can look at a motor car and scale it from a car going, say, pound automobile smacks into the tree, it gains kinetic energy, the half mv squared, the work done is the force times the distance. Is this distance where India smacked into Asia and collapsed all that accretionary wedges into what is now the Tibetan plateau? Can that now be modeled on these equations? Can we now look at the possible theoretical height of the Andes, of the Himalayas, give it a mathematical notation? I'm hoping that Professor Shiga would lead us. Sandy had already started doing the outline of our paper. Her name will be there as a co-editor. And Professor Bezard from Iranian University, who's sent me papers on his mathematics, I would like him to join as well and see whether or not we can actually give some form of estimate regarding the theoretical height of the Andes, where we change kinetic energy to potential energy. Here is Professor Van Heegen's. Here is the passage of India from 60 degrees south to 20 degrees north. There's the accumulated wedge which I've put in. This is my overlay on his drawing. Here it's going, it looks like it's accelerating at the heated formation, the Morondova plume, but then it's suddenly got a deceleration, then acceleration when the Deccan Flats come in, another acceleration further on. And so I'm saying that there is no deceleration periods. At this point, we have not measured, oh gosh, sorry, we have not measured the angular rotation. This is dictating. So it says no different to someone in a marathon going off for a tittle to off the course and coming back again. They don't measure the time, the distance he's gone. They just notice he's taken a longer time from there to there. It's a deceleration. It's a chicane to Lewis Hamilton and Verstappen. And it's that change in angular momentum, which is given rise to this graph. So it could be, we could calculate the actual speed if we look at it and take this into account. Hopefully we'll get hold of that. We can look at this. It's going to be my next project. The mathematical modeling of the planet's rotational behavior and the derivation of formula to offset this center mass as it now allows this movement to be calculated. Introduction of momentum in the study of plate tectonics opens up a new approach as to what forces can be quantified at convergent margin orogenic. Subduction can be realistically considered as being a consequence of plate tectonics over the oceanic lithosphere, and seafloor stretching is introduced in place of seafloor spreading. Convection currents can be considered as having a passive rather than an active role insofar as tectonics is concerned. There is some of this, my work as an engineer. There the lead engineer for the BP team to do the multi-phase ether, so that withstand 3,500 PS, 20,000 pounds per square inch pressure, external, and rotate the internals that go 20,000 RPM. Some of my even odd patent to show my pedigree as an engineer. And I'd like to say thank you to the Harrow Hillingdon Geological Society for acting as a forum to present scientific papers. The late Dr. Symes, gave deep insight into mineralogy. Dr. John Crocker, alternative mathematical verification. Alan Wheeler, invaluable literature survey editing and devil's advocate. Sandy Shawcross, publishing while I was hospitalized. Jackie Gill, illustrations then. Professor Suzuki, Dave Tompkins, Professor Howard, Professor Moody, Professor Harker, for help saying that although I disagreed with parts of it, they said, continue, Bob, continue, because we have to have a handle on tectonics. You are coming close, despite variations between what they thought should be, but at least I was making an attempt. Vicky, who did the first illustrations, and my wife. Mr. Chairman, members and guests of the Harrow Hillingdon, I'm sensible to the courtesy extended to me by your attention to my deliberations. Thank you. Hopefully I haven't run you out of time and patience. Thank you, everybody, for listening to me.
Thank you very much.
How is this not working now?